So this problem is a little bit complicated, but not too bad. It says that a 40 Newton crate, that has 40 newtons of weight, rests on a rough surface, on a rough horizontal surface. So I have a crate, it has 40 newtons of weight, and it rests on a rough surface. We put a 12 Newton force, horizontal force applied to it. We have two different coefficients of friction, mu sub s and mu sub k. And we want to know what is the magnitude of the friction force on the crate. Well, if I look at this and draw a free body diagram, I have my applied force. I have my normal force from the floor on the crate. I know I'm going to have a backwards friction force from the floor, and I'm going to have a weight force pulling down on it. So if I go x and y as my coordinate system, I'm going to have in the y direction, I'm going to have the normal force up minus the weight force down. And this is going to give me my mass times my acceleration in the y direction, which happens to be 0. Or that the normal force is equal to the weight force. All right, now that I know that the normal force is equal to the weight force, I move on to the x direction. And I see that my applied force minus my friction force is equal to my mass times my acceleration in the x direction. Or that my force minus mu times n is equal to ma in the x direction, or F minus mu mg is equal to max. So this last little bit right here was just substituting in that equation we got from our y values. But I still haven't figured out what coefficient of friction I want to use. If I know which coefficient of friction, I have mg. mg is equal to 40 newtons. I have my applied force. I could figure out what my acceleration is. This is perfect. However, I have to check to make sure that this box is moving, because if I have not overcome static friction, then I don't get any acceleration. If static friction implies that the object is still at rest. If that's the case, then my acceleration is set to 0 and my forces will become something different. So let's check. So this is a check of moving. So we're going to check to see if the object is moving. Well, we know that the friction force, the maximum friction force that we can have, is mu s times mg, our normal force times our static friction. So this is going to be our friction static max. So if I plug in the numbers, that's 0.5 times 40 newtons, which equals 20 newtons. So my maximum amount of friction that I can have, static friction I can have, is 20 newtons. I'm only applying 12 newtons horizontally. My friction back is minus 20 newtons. So if I were to look at this, it doesn't make sense that I would even be at my maximum, because the static friction, if you remember from your learning modules, the static friction only counters the net force on this. So if I put 12 newtons on and I have not overcome, or I have not reached the threshold, the maximum amount of static friction, then my static friction is not 20 newtons. It's instead enough to prevent this motion. So really the case that I'm looking for is when this value is equal to 0. So when my friction force and my applied force equal out, I'm still in the static case, I'm still not moving. When I'm not moving, I have 0 acceleration, which means that my applied force and my friction force, whatever it is, it's not actually that value right now, it's still just a friction force. My friction force have to be equal because of this case. So the correct answer is 12. If I don't overcome friction, the box does not move. If the crate does not move, its acceleration is 0. If its acceleration is 0, then there has to be a net force on it of 0. Our y's are already 0. Our applied force is not 0, which means our friction counters that and has to be equal to cancel out the applied force.